Hello and welcome to the next video in the AI series. So previously we'd set up our navigation system and we'd implemented some stuff with behaviors, and in particular setting up so we could have some basic actions for our GOP setup and also some FSM, so finite state machine based ones. So what I want to look at this time around is focusing more in the ProcGen world, but starting to set up some more complex behaviors. So if we take a look at the ProcGen world, there's been a few additions that I've made to it. One of the things is that we now have these villages, and the village, it actually spawns our AIs. So it has a threshold number of ones that it tries to spawn. I've also set up a couple of things like a resource tracker. The resource tracker allows an easy way of being able to identify what resources are available. So for the moment, the villagers, they actually have a perfect knowledge within a radius of about 100 meters from the village. It will have a perfect knowledge of every resource there. So what we want to do is we want to set up some behaviors, because at the moment they've just got their basic ones of wander and idle. But we want to set up some stuff for the AIs being able to gather resources. And we also, with that, if we just set it up so they could wander wherever, an AI is going to end up on the far side of the map. We want something to pull them back towards home, essentially. And there's different ways we could approach doing this. What I'm going to set up is once an AI is beyond a certain distance from their home, they will start to get afraid. And that fear will build. The longer they're away and the farther they're away, the more that will build. And what there will be is there'll be a goal that is essentially a return to home goal. And when that fear level hits a high enough threshold, that goal will become active and will bring the AI back. So the reason for going for that approach, so something that sort of is more of an analog thing sort of building up in the background there, is it creates opportunities for some really good emergent behaviors, because when we have that, we could have other things affect that fear level. If we had a day-night cycle, then when it's night, that fear could build up. Different events, different actions happening in the world could feed into that fear there as well, in terms of increasing or decreasing it, and that's going to affect other behaviors. If you imagine a village that, for whatever reason, there was a lot of things around it that rapidly ramped up the fear level, that's a village that's going to be very tightly constrained in the resources it's able to access, because they're not going to be able to go that far. So some really interesting potential we can get there from just a fairly simple element with the fear aspect there. So we're going to start getting this set up. So inside the goals, we're going to create a goal for return to home, or just return home. We'll also create a goal for gathering resources. So a goal, gather resource, and we'll set up the corresponding actions for these. Initially, we're just keeping these as the mono behaviors, and then we'll customize those very shortly. So, okay, we'll have an action for return home. That's not going to need to be too complex an action. And then we'll also have an action for gathering. So we'll have action, gather resource. And if we take a look at our AI, so we'll look at our villager prefab. So one of the things also set up is this concept of an AI state. So on each AI, it's got a standalone separate state class that can hold a bunch of information. So we'll give it the new goals, so the return home and gather resource, and then we'll give it the corresponding actions. So we've got those set up. So, okay, we need to keep track of the fear, and this is where the AI state comes in. So first thing we want to do is update this AI state. So we've already set up a few different things for it. So the AI state already keeps track of a variable for the fear level, but we're not updating it. It keeps track of the home. So when a village instantiates, when it spawns an AI, it sets the home. And if we take a look at our goal, the goal is also got a few extra things we've added in here. So a goal can always find the AI state or goat brain for it. And if we take a look at our base action, it also can retrieve that state as well. So we've got a few little bits there that we're able to always access. And if we take a look at the village, got a few helpful things in here as well. So stuff in terms of population, spawn points. It instantiates the villages and gives them a name. We also have the stuff for finding the resources in a range, and the spawn points are used as a safe point essentially. So that's something where when an AI is going to return home, it could use one of those spawn points, those safe points, as the destination. So first thing we need to do is have these tracking fear. So we want it that there's a threshold beyond which fear builds. So that's something that we know we're going to need. So that's going to be a fear start distance. We might make it that is 75 meters. So, okay, it's going to start at a certain point. We also need to have a rate at which it builds and a rate at which it decays. So we're going to have a fear build rate, which we want it to be fairly low. So we'll treat 1 as being maximum fear, so 100%. So fear build rate, we don't want that to be too high. This would currently take 100 seconds for it to build up to maximum. We do want the decay rate, so the recovery, to be much faster. So fear decay rate, and we want it to be quite a bit faster. But again, this is something where small little tweaks to these parameters could give quite a big difference, because that decay rate is going to control how long an AI has to spend back at the village before it's able to actually head back out again. So that, again, what an AI encounters, you could affect that decay rate. So if something major has happened for the AI, it might have a really low decay rate. So it's actually having to spend a lot longer there. Or it could have a really high decay rate. So lots of different things that we could be doing there. You could affect that decay rate based upon the number of AIs that are back in the village. So lots of cool possibilities just by having some very simple systems. So I'm going to make it that it recovers twice as fast. Maybe actually, no, I'm actually going to make it 4 times as fast. So if it would take 100 seconds to reach maximum fear, it'll take 25 seconds for that to fully recover. So it makes it quite a bit faster, which is good. So update is where we'll be able to build that up. So I also want it to be, though, that the further out we are, the more the fear builds. So I want to have a float fear multiply, or fear multiply. So this is going to be 25. So every additional 25 meters, maybe we'll make it 50 to start with, give it a bit more of a leeway. So every additional 50 meters, the fear will build up faster. So if we are at 125 meters, then the fear is now building rather than at 0.01, it's building at 0.02. If we were then 175, rather than building up at 0.02, it'd be 0.03. So it's going to continually increase. So I want to get the distance, and in particular, I want to get the 2D distance. So grab this. So first we get the vector home. So we can take the home transform position, get our transform position. We'll get rid of the y component, and then we have distance to home is just going to be the magnitude of that. So that's good. We've got our magnitude. So now we can work out whether fear is increasing or decreasing. So is fear increasing? If it is, so that will be the case where if distance to home is greater than fear start distance. Otherwise, fear is decreasing. So what I would say in that case is fear. And this is where I'm going to use a clamp 0, 1, because that ensures that it stays within that 0 to 1 range. So this is a common sort of way that I'll structure these. So fear minus the fear decay rate by time dot delta time. So that's good. And the increase is going to be fairly similar. Rather than being minus, it's obviously going to be plus, and it's going to be a fear build rate. But we need to take into account that multiplier. So we need to take our fear distance minus, so our distance to home, subtract from that the fear distance. We then divide that by the fear multiplied distance. So every time, and we don't want this to move continually, we want it to be sort of a lockstep thing. So every additional 50 meters, it goes up by 1. But in between that, in that range, it's not sort of slowly creeping up, so it's a lockstep sort of thing. The reason for that is that we want it to be something that is a more overt change. If it's just a gradual one, people aren't going to really notice the change, but if it's a really overt change, especially if that multiplying factor was much higher, that's going to be something that we notice that change. So I'm going to say fear multiplier, mathf, and we'll do a floor. So we'll round it down, and we do a 1 plus. So that means for that first 50 meters beyond, it's going to be 1, but then it goes up to 2, 3, etc. Because then we can throw that in here as a fear multiplier. So it's good. We've now got this fear aspect that the AIs can refer to. So that means our return home goal, we can start to set that up. So this is going to, as before with the others, come from base goal. We're going to really, if we take a look at our other sort of goals that we've got, Wanda did a lot of stuff there, and there was bits that it was doing in wake up and go to sleep. We really just need this pre-tick. So this one from idle is actually a good starting point. We'll bring this in. So priority is actually going to be fixed at 100. This is something where this could be a useful thing to define here of what the maximum priority is. So public const int max priority is 100. And then we'll be able to access that here. So our max priority. So it's the can run that we want to actually adjust, because return home is essentially, it's a safety, it's a fallback thing. It's something where when it kicks in, it kicks in. And we could actually kind of cheat and go max priority +1, things like that. There's a lot of stuff we could do in terms of setting some gating of priority ranges, which if we've got a lot of goals, would absolutely be a thing we would need to do. Balancing those different priorities is really important. But for this, what we can do is we can set some thresholds. So max. So we've got 2 thresholds that we really want to have here. A threshold for when it starts to return home, because the fear has reached such a high level, and a threshold that the fear then has to drop below before it to no longer be compelled to return home. So panic start threshold, which I'm going to say is 80%. Range. So that's going to be, once the fear reaches 80%, then the AI is going to go, nope, I'm going to run back home. but then it's not going to exit that sort of panicked state until the fear gets a lot lower. So panic end threshold. So this should always be lower. So what we would be saying is, well, if we're active, so in other words, this goal is currently running, then F, linked AI state, fear, is below the panic end threshold, then can run becomes false. Otherwise, can run would be true. So we could actually rewrite this as can run if linked AI state dot fear is greater than or equal to the panic end threshold. So can run will, when it's active, can run will not go to false until the fear level goes below that. Otherwise, so if we're not active, then we can run if that fear level is greater than panic start threshold. So we'll start panicking at 80% and then we will keep panicking, keep returning home till we hit 20%. So that's it for the goal. Priority is always going to be max priority. We're gating things with this. So that looks good. So then for the actual action for this, it doesn't need to be based off of the FSM action. The reason being that we don't really have much of a concept of state for this. It's really just doing the one thing. So we're going to give this the base action. We will use wander as a bit of a template. So bring that over. We'll grab, actually idle as a template. We'll bring that in. So cost, again, because this is something where we're not really having different ones to satisfy the same thing, we can keep the cost as 0, but goal return home. So that's good. So when this begins, that's where we want to pick a destination. So that's where we have our safe locations that we can ask the village for, which we can access the village via that linked AI state. So we can say, okay, well, get a random safe point, and we can go navigation, set destination to that. So that looks good. Now this is something where generally we should be able to assume that this will always succeed, because we're heading back to a location that we have locked in as this is a definite thing that we can hit. So there shouldn't be anything that causes us to not be able to reach that. Now, if we had an environment that had dynamic obstacles and obstructions, that might be different. We might have to go and do some extra checks there of, okay, well, what if I can't get to this safe point? Is there another safe point I can get to? In this case, we know that we've got these valid safe points that we can go to. And then on halt, we can tell it to stop movement. So that looks good. We've got all that we really need for that, because there's very little that it has to do. Now, one thing that we can do is something I added in was the goals actually have a function that allows you to return some extended debug info. So I'm going to use that for the return home goal. And I'm going to say that what this will do is it's going to run the base version of the get debug info. And then we're also going to chuck in a new line. And then we're going to say fear and just output what that current fear level is. Because that would be really useful to be able to see that. So linked AI state dot fear. So, okay, we've got our goal set up, has those thresholds for the panicking and then for the returning back. And we've got an extra bit of debug info there, which looks good. So let's test it out. Let's see what happens when we run this. So we'll get this up and running. And so we'll see, obviously we'll have a lot more AIs present, which we do, and we can see their current status, they're going and wandering. So it'll take a little bit as they sort of scatter away, and then we'll see fear start to actually build up for some of them as they manage to move farther and farther away. In particular, some of the ones like this one over here. If we can select that one, so that is, if we go to that particular one and just select them again, we'll be able to, so that's village 1, villager 2. So their fear level, if they keep wandering, is probably going to hit that sort of threshold fairly soon, because it was 75 meters, which is going to be sort of roughly this range. But it has now gone and wandered back. But eventually there will be ones that will start to hit. And we do also have our other set over here. So this is ones where this particular AI here is bound to be getting scared by this point. So that's village 2, villager 5. So let's check their stats. So we can see their fear is building up. So they're already at 23%. They're going to keep heading away, which means that's going to keep building up. And it's going to probably start building up faster as well, because they're because it's just completely random the directions they head in. So that's already at about 50%, because what we're expecting to see is, assuming they don't randomly pick to head away, which they haven't so far, which is good. So they haven't returned back. So they should be about to hit the 80% threshold, and it is increasing pretty rapidly, the fear. And what we'll see is when it does hit the 80%, immediately return home kicks in. Now that actually hit an issue with that iteration budget, and that's because they're trying to pathfind from just so far away. So this is a little bit of a danger with the stuff where they can hit issues where they can't actually pathfind because of how far a distance they need to go. So that's something where, for the particular AI characters, what we're going to do is switch them over to, because we set them up so they were using the synchronous pathfinding, we're going to set them over instead to be using asynchronous pathfinding. And then in the pathfinding manager, remember we've got the ability for having a much larger budget, because it can do a number of iterations per tick. It also has a larger iteration budget per cell, which that we can actually increase that even further. That's just going to mean that the AIs are a little bit more capable of being able to find a path back. It does mean they will be a little bit slower initially moving, but it will also help to balance out the actual sort of overhead for them. So it'll distribute the workload a bit more over a frame. And providing we've got other stuff that the AI could be doing, so some decent idles, things like of that, can kind of get away with it and people won't notice really what's happening. Because we've got village 1, villager 7, their fear level, if they continue heading in that direction, it's probably going to, so it's immediately they've crossed that threshold, it's starting to build. So this one, hopefully with the revised budgets now, is going to be able to sort of find its path back. But that's also something where, balancing those budgets is an important thing. And it could be a case where stuff like of this, where we know it's going to be a really long path, the navigation system can actually make the call between doing a synchronous or an asynchronous pathfind. So the navigation system could look and see, okay, this is a pretty short path, so I'm just going to make it a synchronous one. whereas for a long one, it could then switch to asynchronous. So this AI is going to hit the threshold very soon, hits return to home, and now it's starting to head back. And likely, we'll see potentially even at the other village, some ones that have already had to return home over there. So this one will start returning home. Its fear level is at max, but it will return and it will hold there until it starts decreasing. And what we'll see is there will at times be clusters of AIs that will choose to then go and return home so that they can actually recover from the fear. And we can see its fear level is starting to go down pretty rapidly, which was what we intended. We did want it so that it's a pretty rapid reduction in fear. Once it hits 20%, that's going to switch off, which it has. So then now the wander goal kicks back in. So that's good. We've got that initial thing we were after of them having something that's compelling them to return home, but something that's compelling them to return home that we have a lot of not just control over, but interesting control over. As I said, being able to have stuff like, okay, time of day affects how far out they're prepared to head. It immediately communicates a lot more intelligence to the player. If it's something where you see nightfall and you see not just their fear rapidly increasing, but that they flock back, that's something that works really effectively. And we're using it for sort of villages here, but you could be using it for creatures in your world, and it could be tied to all manner of different things. So really, really effective sort of technique there for it. But now we want to focus on gathering resources. And this is an interesting one because we're starting to set up a higher level of AI. So generally when we're talking about AI, and in particular, this is most clearly defined in something like a real-time strategy game, we often have AI at different layers. So you have sort of the tactical layer of AI, where when we're talking about tactics, we're talking about working out sort of short to medium term plans to achieve a particular objective. So, a tactic, you're talking about things like, returning home, gathering a resource, stuff like that. But then you have strategic AI, and that's determining things like, okay, well, what resources should we be gathering? Should we be gathering resources? What are our tactics that we should currently be employing? So we want different levels of AI often for our characters. And that's a really critical thing of being able to make that decision between how these things should work. And different AI techniques fit for different sort of stages. So, for example, GOAP, things like that fit really well for sort of prioritization. So GOAP would work well for a strategic AI. State machines, to an extent, yes, but a state machine works well for something where you could divide those strategies into very clearly defined states. So a good example there is Medieval 2. There was very clearly defined states for defending a settlement. You could be protecting walls. You could be skirmishing in the streets. You could be falling back. So very clearly defined states. So a state machine worked well for that. But something where it's more sort of messy and organic, that kind of structure can be a little bit too rigid. So something like GOAP is going to work a little better there with that, where it might have multiple priorities. But in this case, we need an organizing principle, for want of a better word. We need something that is deciding what is the priority at the moment. And that's where the village comes in. So the village is actually best placed to make that call of what should the AIs be doing at the moment. Because the village is effectively the hive mind. If you needed an in-world analogy for it, the village could represent, some governing authority there, something that's controlling, leading the village. So it's the best placed to make that call. But we need to give it the tools to make that call. So what I'm going to do, and again, we're going to focus on some key aspects of this, not necessarily on having the village AI be really great, but focusing on it providing answers to the questions that the goals have, so that we could then later on set up some more sophisticated AI for the village. For now, it's going to be a very simple way in which it allocates, tasks or jobs to the AIs, but we'll be able to be setting this up so that it's able to be expanded later. So first thing is we need to give it a way of being able to know how to do that. So it already knows the number of villages that it has. And we could say, well, I want a certain percentage of this allocated to gathering resources. So, okay, that works. So a range, 0f to 1. So that would be a float gatherer proportion. So we might say that 60% of the villages should be focused on gathering. That means we need to track what our gatherers are. So I could just have a list, which would work, but I also need to know what they're gathering is important. So we've got different sort of competing things we're trying to track here. We've got information in terms of the number of gatherers we've got the type of thing they're currently assigned to. So what I would do for that is, this could be a good use of having a dictionary. We're going to have a goat brain, because that's our easiest way to talk to an AI. And then we're going to have world resource E type. So this is essentially going to be the job allocations, or the gatherer allocations, or gatherer assignments. So that's good. That will allow us to track what ones have been assigned. But we also probably need to know, just in general, which ones are available there. And if we take a look at resource types, we've only got our food, water, wood. So I'm also, even though it seems like, okay, we're tracking a lot of similar information, it's going to make things a lot easier for us. So this is going to be gatherers, because we'll assign someone as a gatherer before we give them an assignment, because assigning someone as a gatherer happens in the goal. Their assignment will happen in the action. So, okay, well, a goal is going to need to be able to go, hey, do you need me to gather stuff at the moment? So that's going to be, we'll have public float, because we could express this actually as a priority. How urgently do we need gatherers? Get gatherer priority. So what we can do is we can work out how many gatherers are we trying to have, because we know this gatherer proportion. So we could do gatherer proportion multiplied by, we know the number of villages. Got that being stored, as count. So, okay, we've got the number of villages being stored. We're adding that in there, which is good. We're going to floor that to an int. So this is desired num gatherers. We also have our current number of gatherers, because that we're tracking in a list. So that is going to be gatherers.length, or count. The only reason I'm putting that into a separate variable at the moment is it makes it a little bit easier just to see. Because then we can work out our surplus gatherers. And the surplus gatherers is going to be, we take our current and we subtract desired. Now the handy thing with this is if we have if there are more gatherers than we need, surplus gatherers is going to be 0 if we're at the exact right amount, or a positive number if we've got too many. So we're going to say if surplus gatherers is greater than or equal to 0, then the priority is 0. We don't need gatherers at the moment. Otherwise, so if we say our target is 6 and we currently have none, surplus gatherers is going to be 0 minus 6. So it'll be minus 6. So if we did cast it to a float, if we did surplus gatherers divided by the desired number of gatherers, then when we have absolutely none, that would be 1. And the more gatherers we get, the closer we get to our threshold, the lower that value gets. That works really well as a priority. So we can return, not that it's strictly necessary, actually we don't need to do a clamp, but we do need to do an absolute value because it's actually a negative divided by a positive, which would give a negative number. That will work for giving us a priority for this. The more gatherers we get, the lower that priority will be, which means other goals can take priority over that, which is great. So that works. So we can set up that goal then for the gathering. So if we go to the gather resource goal, and that is again going to be based off of base goal. Similar to what we did before, we're going to just take directly from the idle. So whether it can run or not is going to depend a little bit on the priority we get back from the village. If the village gives us back a priority of 0, it absolutely cannot run. Otherwise, we don't necessarily want to directly use the priority that the village gives back. We still want to have some control there where we're setting the priority. So have float min priority, actually not a float, it's an integer. So if a gatherer is needed, we can say, okay, well, at a minimum, that priority is going to be 25. And at maximum, and we'll need to fix up the name of this in a moment. So we might say the maximum is, probably not 100, maybe, but we might go for whatever the maximum one is there. So if it's really desperate, we focus on gathering resources. So we'll just rename these like this. So what it will mean is if we're pretty near to having the most, all the gatherers we need, it's not going to apply as high a priority to it. Whereas at that early stage where it's a case like, nope, people need to gather stuff, it's going to be much higher. So, okay, that works. So we could say then our linked AI state, home, and we could get the gather priority. So gather priority. Now that, if that's 0, we definitely do not run. So if gather priority is less than or equal to 0, then can run is false. Priority is 0. We do not attempt to run. Otherwise, can run is true. And our priority is a lurk from min gather priority to max gather priority using that value we already received. So it's going to be a little bit grumpy here. We just need to go and do a round to int. So now we have this, its priority will be changing, which is great. But we also need to have a little bit of communication with the village saying, hey, we're now going to start gathering stuff. So that's okay, because if we take a look at our wander goal, we've got a couple of functions here for when a goal wakes up and for when a goal goes to sleep. We could also, in here, if we are active, if we are running, we make no changes. So F is active, return. Priority cannot change while running. So if we've chosen, we've started a gather mission. Our priority is locked. We do not change it. So the only thing that then can take over is a more important goal. Otherwise, our gatherer priority here would actually slide and adjust with each new gatherer that gets assigned. So the priority would progressively go down, and these would then get shut off by the fact that, simply by the fact that we've assigned more people to gather, which is not what we want. We only want that to change when they become active. We want to be able to tell the village, hey, we're going and gathering stuff now. So we want to be able to go, hey, linked AI state, home, add gatherer, and linked brain, and then we want to, in go to sleep, be able to remove that. So we want to be able to remove a gatherer. And we'll set these up here so it's populating things. So we'll have an add gatherer, and that's just going to set this up where we add that to this gatherers list. So we do gatherers add brain, which is good. And then we'd have a similar thing for the remove. So remember, we have remove gatherer. Again, takes in a goat brain, and it will just go and remove that. So, okay, we've got the goal side in a good spot. The village is able to tell us how important it is for us having a gatherer at the moment. The gather resource goal, if it's already running, cannot change priority or whether or not it can run. Otherwise, it grabs the priority. If that priority is saying, yeah, no, I need a gatherer at the moment, then what will happen is it sets its priority, locks that in at that stage. Otherwise, it will go and just switch off. So we locked in the priority so that then as we add more gatherers, it doesn't go and just automatically switch off all the AIs. It would be a really frustrating bug that we could very easily run into. And then when we become active or when we go to sleep, we just tell it to add or remove the gatherer. So that's good. We've got the goal for it. Now we want to have the action going for it. And this is one where what we're going to do is this gather resource. This is an excellent use of having an FSM action. So have our state, and we will link it to that. So it's going to be linked to the state. So we obviously then, there's a few key functions that we need, which we can go to Wander, and I'm not going to keep most of the stuff from Wander. I will grab all of the contents just because it provides the key things that we need, but we're not going to actually keep a lot of the bits and pieces here. We're just really wanting the essential functions that we absolutely have to have. So we'll get rid of most of these. The goal that it can satisfy is a straightforward one of gather resource. So excellent. We've got the skeleton there. We're now in a position where we can start to define what our gather resource action looks like. One of the first things the gather resource action is going to need to do is determine what resource to head towards. So this is where I was saying the goal determines that it will gather. The action will determine what it gathers. So this is going to pick resource. That's going to be the first state that it goes into. Then we need to move towards the resource, move to resource. Then we have collect resource. So, okay, we've moved to it. Collecting it might take time. Now we need to head home. So we'll have a return home. And then when we're back, it might actually take time to offload that resource, to store it. So store resource. So these are going to be the key states that we have. So this is something where what I would do is an easy way for setting up those states. Just going to do this. This is where multi-line editing comes in very handy. So we'll do add state, eState dot, and then it's nice and easy. So, okay, we've got a few key states that we need to be doing here. So pick resource is going to have to work out the particular resource to actually head towards. That's going to be something that it's going to be up to the village to tell it what resource it heads to. So for picking the resource, we need the village to be able to make the call on that. Because remember, we set up so that the village, we add things to a list. And then we also set up a dictionary for keeping track of the assignments. And what we want to do is we actually want to keep it reasonably balanced. If we've got, a certain number of characters, we don't want everyone gathering water, for example. We want to actually have it be a little bit balanced there. So what I want to be able to do is have something where, similar to the get-gatherer priority, I want to be able to have a resource get gather target. It's just going to return a world resource. And I want it to have a particular character that's going to be doing the gathering. So, okay, we need to work out which resource we assign them to. So I want to actually check and see how much of each resource we're currently sort of trying to retrieve. So I've already got stuff where I'm doing things like looping over all the enum values for the resource types. So what I could do is anytime I get a gather target, check that dictionary and see how many do I have that are grabbing food, how many grabbing water, how many grabbing wood. So list, and we're going to go float. And actually we can do better than that. We can go, okay, E resource or world resource, E type, best type. Actually, no, we'll do the outer loop first. So we've got our resource types. What we want to do is, because we need to build up a count. So we actually do need a list of integers, num gatherers for type. There's a new list. So we loop through each of the resource types. So resource type in resource types. Then what we do is we find all of the entries in our current gatherers to see if they are actually tracking that resource. So what we would currently do is, num gatherers for that particular type, which actually we don't need that list, no. So num gatherers is equal to 0. Then we can find the number of things in our dictionary that are gathering that resource. So the simplest version of that, so for each gathered resource in gatherer assignments dot values, and then we can check if gathered resource is equal to resource type, which that resource type, we can cast that to the world resource E type. We tend to need to when we've retrieved an enum in this manner. So if it's equal to it, then we add the number of gatherers. So, okay, we've determined how many are gathering this resource. Determine how many are gathering this resource. Because we're looking for the resource that has the lowest number of people gathering it. So, okay, that will tell us that we've got 0 for this. So int lowest num gatherers, which I'll set that to max value. And we actually will have eType target resource, because what I would then do here is, okay, well, if num gatherers is less than the lowest num gatherers, then we set lowest num gatherers to be this, and we set the target resource to be the resource type. Good. So in this case, found a new best target. Now this will always find something as long as we have someone gathering a thing. We might not have someone gathering a thing, which we won't at the very beginning. So find the resource most in need. What we can do is have a default resource that we try and gather. So serialize field, world resource, eType, default resource, which this is the one that the first thing that we try and gather will be this. So I'm going to say that that will be water. So we'll try and gather water. So, okay, that's going to be default resource. So we can then reliably assume that this will have a particular resource now to assign, to grab. So what we want to do is check and see, okay, let's find a resource that matches for this. Now, with the resources, we've got them here in this tracked resources type thing. So what would be great is to find the ones that are closest to the brain. So I've already got link added in here, because I can actually, with link, do a really easy way of doing this. So for working with the resources, what I can do is I can actually use link for this. And what I would say is tracked resources and our target resource. Then I can say order by, and I want it to be in ascending order, so closest first. So resource, and then I use vector3 distance, and I use the brain's transform position, and then I use the resources transform position. So resource transform position. So this is going to give me a list sorted based upon how close it is to the actual AI. So I'm going to say to list the sorted resources. So I've got that. So then I want to pick a random one in that, but I want to weight it that I pick one in the, say, top 10. So I'm going to say return sorted resources, a random.range from 0. Now I don't want to just do 10 because I might have, say, 3 there. So what I want to actually do is be able to say the mathf min of 10, which we'll put this into a variable in a moment. But that and sorted resources dot count. That way then it can never go over the length of the container. So we'll set this up here as a serialized field int resource or gather pick range. So it's going to be the range within it picks. So we'll sort them and then it picks randomly within that top 10 one. So that's good. We also then need to, when we're actually done that, we need to apply it into the assignments. So we'll also then say here, gather our assignments. And for that particular brain, it's going to be assigned to target resource. When we remove a gatherer, then we're going to go gather assignments, remove, and then also provide that brain. So that looks pretty good. Now it is possible that we might have no valid resources. So we want to check that first. So we want to check if that count is equal to 0, then we return null. So it's going to be a bit of responsibility on the action to interpret that properly. But this will give us a gather target, and it's just as each new action kicks off, it's going to balance out those priorities. So for setting up the states here, we saw with Wander that we set up the individual functions. I want to go for a little bit of a different approach here, where we do have just the core set of functions, and I'm going to use those. So we're going to set these up here. All of these need to get flagged as override. And this changes to eState. So in on enter, we need to pick the resource. But we only need to do that in that particular state. So I'm going to set up a switch. And we're going to be using this a lot. So what I'm going to do is, again, I'll actually use this set of ones because it's already got the blank lines removed. So these will become a case. This is just going to be our setup for all of these, just so that we've got this ready to go. Because each of these functions is going to need this, so it makes sense just to get this set up once, and then we'll transfer that into each of these, and we'll then populate it. So, okay, on enter for pick resource. Well, we know already that needs to go to linked AI state. It needs to go to the home. And it needs to, if we ask it for the gatherer target. So this is one where then what I would be keeping track of up here is world resource target. So get gatherer target. We give it the brain, which if we take a look at our base action, we don't currently have that. But we do need to then provide that through. So we go brain, and we use the same naming that we used here, so linked brain, just keeping it consistent. So it's always good if we can keep these consistent. It just means that you're not trying to remember several different terms for the same thing. So, okay, we've got the brain there. So linked brain. And we can say target is equal to this. So pick resource should give us back then a target. So in on tick for pick resource, there's not anything we need to do. We could be checking what, if say it failed to pick one. So that would be something where we'd probably do a transition or something like that there for it. But it might be something that we want to do in pick resource if it's actually failed. Nothing in the on exit. It will do absolutely nothing for that. Check transition though. Well, if target is not equal to null, then we return move to resource. So that's a valid thing there that should go to move to resource. Otherwise we stay in this state and we rely on tick making updates to it. So tick will need to do some check for if the target is null. We could just repick, but we probably want to maybe do something a bit more than that. For now, I think I will actually just say, well, if target is equal to null, then repick It's a very unlikely scenario to happen, to the extent that I would say if it does happen, we've probably got a bug somewhere more than anything. But okay, that's good. So move to resource now. Well, move to resource, we can only enter it if we've got a target, which now means we can tell the navigation to head to that. So we can go, okay, well, navigation, set your destination to the target, and that target, it's transform.position. So we want it to move towards that. So that's good, but remember, that could actually fail. So that's something where move to resources tick. Probably don't want to do anything there, because that's something where if it's failed, we actually should handle that in a transition, so have it return back to, say, pick resource, which if we look at our wander action, we did have stuff here in terms of, okay, if it doesn't have a position, if it's failed, then, and this one in particular is the one we want to actually check, then we can return back to the other state. So this is something where for its transition, we'd be saying, well, if this is the case, then return back to pick resource. So on failure, we go back and pick another resource again. So that's good. So, okay, we've got picking resource, we're able to move towards a resource. If it's not finding or following a path, it might be at the destination. So we can check if is navigation at destination. If it is, we go to collect resource. So collect resource can take time, and we want it to actually be able to take time. So that's going to be something we set up here. Serialize field, float, collection time. You might say it takes 5 seconds. Have another one for storage time, because we know we're going to need that. And then we can keep track of the action progress or action time. So that's good. Or action time remaining. Because what we would do is when we enter collect resource, well, action time remaining is collection time. When we go to store resource, action time remaining is equal to storage time. Then in our ticks, well, if we are in collect or store, action time remaining, we update. So not too much that's needing to happen with it. So this is why, setting up the state machine like this can be fairly, neat, clean sort of setup. On exit, actually probably nothing we need to do per state, but we can have our generalized stop movement. That's going to be valid for any of them. But then our criteria here, well, if action time remaining is less than or equal to 0, then we need to return home. So we return eState, return home. If we're storing the resource, this is an interesting one. So action time remaining, if that is less than or equal to 0, we need to actually stop this action. We need to prevent it from running. So for now, I'm just going to put that in as a debug log to come back to, because I want to finish implementing the remaining bits for this. So, okay, that's good. It's going to run those parts. Still need for returning home, but that's something where we already have a bunch of stuff for return home. We already know what that return home action looks like, which is this. So we can just go and bring that in. Now our logic here, again, for, we don't need anything there for the on tick for return home, but the transition, we do need stuff for. So if it has failed, That's going to, again, be a bit of a tricky one. For if it's at the destination, that's easy. It does a store resource. But this is one where, again, if on its way for returning home, if it's actually, lost the navigation points, something like if something's essentially caused it to not be finding or following the path, that's something where we could have it repath. So in the on tick, we could have eState return home, chuck in our criteria, and then for this, we'll just have it pick another safe point. Now, it really should not be possible to have happen. It's really a fallback thing. It's unlikely enough that it would be worth putting in a debug for. So debug log error, and we can log out our name. Fail to return home, picking new path. Unlikely, but worth us having just there as a fallback. So if it's not finding or following the path. So, okay, let's check through our logic. We enter pick resource, we pick one. In the tick for that, if somehow that's gone null, we repick. Again, it's probably a good one to have an error for, so a similar thing. Failed to pick resource. Picking new target. So, okay, it's picked, it's checking, it's got a little bit of a fallback there. Once it has a valid target, then it will start moving towards that resource. Move to resource sets the destination. While it's doing that, if it's finding or following the path, if that has failed, so if it's not finding or following the path, we go back to pick resource. Otherwise, if it's at the destination, we collect it. When we go to collect the resource, we set the time remaining. In tick, we reduce that. And then the transition, we go to return home. When we go to return home, we set our destination to a safe point. If on the way returning home, we're no longer finding or following a path, we log out an error and find a new one. Once it's returned home, we then go into storing the resource, which again takes time. And again, we set that storage time, decrement it in our tick, and then check for if that's gone below 0. So that's one where there, we need to be able to tell it to stop this action and to actually interrupt it. And that's something we haven't needed so far. Up until now, goals and actions, what has controlled whether they run, is based off of their priority. It's not down to anything else. So this is something where we need a way for the action to be able to tell the goal, I'm done, I'm finished running. So what we're going to do is there's a few different ways we could go about this. So actions don't know the goal associated with them currently. And I think a better way of having this work rather than the action pushing something to the goal is something that the goal can ask the action. So we can have protected, actually this will be a public bool has finished, and this will be a public get but a protected set, and it will default to false. And what we will do is when an action starts, it will go and run and set that it hasn't finished, and then afterwards it's going to go and run its normal logic. So this would allow us to, in this, say, okay, it's now finished. Also means in our, on enter, because remember for the FSM action, we don't have access to the onEnter, but we can actually reset this here. So has finished is equal to false. So that's good. So we've got something that we can query, something that we're setting when we are done. So then the goal, if we go to our goal, because remember the ticking happens through here. So we can go, well, if linked action dot has finished, then that's something we could also have that bubble up to the goat brain, because while the goal can access that, the brain actually is the one that probably should do the logic for this. So we can load up the brain and we can see here where it's ticking. So what we would do is, okay, well, if active action has finished, then we already know what we need to do for, terminating a goal. We tell it to go to sleep. We tell the active goal to go to sleep, and we set the active goal to be null. That's going to force it out of that finished state, and then it's going to mean that it essentially re-rolls all of its priorities because it's no longer active. So if action finished, clean up the goal. And we'll also clean up the action as well for good measure. So active action will also go to be equal to null. So that looks good. We've got all of those bits of information there. This should then be able to run. So let's run this up and see what we're getting behavior-wise. What we're looking to see is a number of ones doing the particular different tasks that we've assigned to them. So we'll run this. So we'll see the stuff populate in the debug window. And what we want to do is check initially. So we've got gather resource, another gather resource. So the first 6 villages should be assigned to gathering resources, which it looks like they are, which is good. And then if we take a look, villager 7 is not, 8 is not, and the others are not. So a bunch of ones are not gathering resources. Now we don't know what resource they're trying to gather. So again, that would be useful information to be able to display that. Now the goal doesn't know it, but the action does. And if we take a look at our AI debugger window, it is getting info from the actions. And we do have stuff there where it's grabbing, the particular name in that. That would be very easy for us to then grab a bit more sort of extended information there for it if we wanted to. So what we could be doing is here, we could actually just add it onto this. So what I'll do is in the goat brain, not just the name, we're also going to have it that if we have an active action, so we get its name, and then we'll also chuck in active action get debug info, and we'll set this up so all actions can implement that if they want. So our base action, just have a public virtual string get debug info that for most things is just going to return an empty string. But what I will do for our specific one is we will actually grab out some extra info there. We just need to close off that. So then for our gather resource, override, we're going to provide firstly, we won't put in a new line for this. We'll just provide state like that, and we'll provide the target type. So not gather resource. This actually goes into, we missed that. That's supposed to go into our gather resource action. So we'll provide the state and then the resource. And that's going to be, we'll just put target, because that way then it can also indicate if it's null. So if we go to test this, we'll run this up and see what's happening. So we're focused on village 1 here. So if we look at the first villager, you can see they're in gather resource, and if we expand, so they're heading towards food. You can see it flips a lot between what it's heading to, and that's because if we take a look at the code, we actually, when it's at the destination, it isn't actually finding a following path. So this is a order of operations thing that we have gotten wrong here. Really easy to have happen, so it's something to always be cautious of with this for checking that the order that you're actually doing things in. Really, really important. So, okay, if it's at the destination, we go to collect, otherwise we go to finding a following path. So that's good. So if we run that again, we shouldn't see them flipping as much between the different target resource types. So we'll get this running. So villager 1 is heading towards food, 2 for water. So we'll keep an eye on these ones. So it's gone to food. One's collecting, that one's collecting. So we should see them go to returning to home, which they both have. They're returning home. So they're coming back. They're now going to then, once they're back at their sort of home point, we would expect them to go into the storage state. So that's something where they're not going into the storage state. So again, if we take a look at the code, and we could see they were saying they were failing to return home. So what we want to do, and there was quite a few ones, were failing to return home. So we want to take a look and see what's potentially happening there. Because yes, we were getting this message saying that they were failing to return home. But again, that same issue with the destination, because check transition is done after the checking of if they're at the destination. So we want to say, okay, if navigation, so in particular, if it is not at the destination and it is not finding or following the path, then something is wrong. So really important, we ran into an issue here. Very, very easy to run into sort of issues like this because of the order things run in. So it's just an important thing to be cautious of with it. So we'll test that again. And hopefully we should see them head back, store resources, and then they pick a new thing to do. Might be gathering a different resource, might be going off and doing something else because the priority will be different at that point. So villagers 1 and 2, both are going and grabbing food. So we've got a few different ones. One's currently in collecting a resource. Both of those are collecting. We've got a couple of ones here that are returning home. You can see they're in return home. Once they're back, we should expect to see that it goes to storing. We can see storing a resource. Both of them are doing that. So one was doing food. Now these switch over to wander because it's not as high a priority for things to be gathering. We will run into ones where they run into paths that don't exist. That's to be expected because wander just picks random locations. But we've got a bunch of our villagers going and grabbing resources. And if we expand all of these, so you can see we've still got quite a few that are gathering resources. So one has gone to idle. As different ones pick and swap between different things, they'll generally balance in terms of what they're trying to achieve. And it'll keep around that similar amount of ones gathering, because we can see later ones, which this actually works out really well. And now one's back gathering again. We've got a bit of to and fro there. They're balancing out the objectives that they're doing. But they're also having to balance fear, because fear will override the priorities there. So this is great. We've got our village working. We've got them going and gathering resources. Now, they're not using them for anything at the moment, and the prioritization is quite basic, but that's okay. That prioritization, we can do more with that. And they have perfect knowledge of where to find all the resources, but again, we can do more to improve that. The idea is we're setting up a base to build more complex behaviors upon this. And the key thing with the stuff we're doing today with this is just having simple little elements like fear and things like that as ways of being able to have interesting behaviors just emerge. Because now it's a balance for them. The greater that fear builds, the less they'll be able to expand to go and actually gather more resources. So it gives really cool interactions there. Thanks, folks. I hope you found the video helpful. If you're looking for the code for the project, the code is available on GitHub. What I've been doing for all of the videos in this series is setting up a tag for each video, so it'll take you direct to the code for this particular video. If you found the video helpful, please chuck in a like and subscribe. It's something that really helps out. It's really appreciated. If you've got any questions, chuck in a comment below, or if you want to submit the questions for the next Q&A video, you'll see the link for that in the description too. And if you're looking for other ways to support the channel, then I do have a Patreon, and the link to that's in the description below. But until next time, bye.